Let's do a quick review of how to solve compound and absolute inequalities. If I wanted to graph x is between is the key word here, -1 and 3 not included, I would graph -1 and I would graph 3, and then it would be everything in between. I'm going to use parentheses on the ends because -1 is not included and 3 is not included. If I wanted to graph x is greater than -1, or actually if I took that last one apart, it would actually be x is greater than -1 or x is less than 3. If you start with the x in the center and you read to the left, you get x is greater than -1. And if you went back and looked at the x in the center and read to the right, it'd be x is less than 3. And that's how we come up with this. Between is the key word here for absolute value. We're going to talk about the graph being between two numbers or outside of the two numbers. So if I wanted to solve and graph -3 is less than 2x plus 1 is less than or equal to 3. Obviously, this x is going to lie between two numbers. We're not sure what they are yet because we have the 2x plus 1 in the center. But what we're going to do is we're going to employ all of the things we know about algebra and about solving linear equations. So I'm going to start by adding or subtracting 1 from both sides because I want to get I want to eventually get the x by itself. So if I subtract 1 from both sides, then I'm going to have -4 is less than 2x is less than or equal to 2. Now what do I have to do? Well, I got to divide everything by 2. And when I divide everything by 2, I get -2 is less than x is less than or equal to -1. So that is the first part of the solution. And I know that when I graph this, I'm going to have my x is going to lie between two numbers. And those two numbers are going to be -2 and +1. -2 is not included, +1 is included, so that's what the graph looks like. The definition of absolute value is distance from 0. Distance from 0, and distance is always positive. So let's take a look at a couple of examples here. If I say the absolute value of x is less than 3, that means that x distance has to be less than 3 from 0. And so that's going to confine it a little bit. If I have the absolute value of x is greater than 3, that's going to mean that it's going to be farther away from 0 than 3. So if I graph, going back to my absolute value of x is less than 0, that means that my outside points are going to be -3 and 3, and my graph is going to be inside because it's less than 0. The distance from 0 is less than 3. When I have the absolute value of x is greater than 0, that's going to mean that the distance is greater than 3. So it's going to be either 3 or less or 3 or greater. This is going to be in interval notation, or in notation. -3 is less than x is less than 3. Over here it's going to be x is less than -3 or x is greater than 3. And I hope you remember that from your Algebra 1 and Algebra 2. Okay, let's do some practice. If I have the absolute value of x minus 4 is less than 3, I know that it fits into the category of absolute value of x is less than a number. Less than a number. So if it's going to be less than, that means it's going to be confined between two numbers. And that's going to be written like x is between -c and +c, or whatever your final number is. So I'm going to have x minus 4 lies between -3 and +3, and that's how I'm going to write that out. If I add 4 to both sides, I have x lies between 1 and 7, which means if I graph it, I'm going to have parentheses at the 1 and at the 7 because it's not included, and x is going to be lying between So I'm going to have the two numbers connected in the center. Another way to look at this, if you would graph the equation y equals x minus 4 on your graphing calculator, and it would look like that. And if you would also graph y equals 3, it would look like that. And so graphically you can see that it's going to be between 1 and 7. The solution set's going to be between 1 and 7. It's just another way of doing it. This is a visual solution to our problem. Okay, let's do this next one. I am looking at what looks like it's going to be a greater than number. And if it's greater than, then you're going to be graphing on the outside, to the left and to the right. But don't do that yet, because what you need to do before you decide what kind of graph it's going to look like, you have to get the absolute value all by itself on one side of the equation. And we still have some cleanup to do. So what we're going to do is we're going to simplify first. So if I simplify by subtracting 7 from both sides, and I'm going to have negative 2 times the absolute value of 3x plus 5 is greater than or equal to negative 20. Now if I divide both sides by negative 2, that's going to switch my sign around, flip it around. So I will have the absolute value of 3x plus 5 is now less than or equal to 10. Now I have my absolute value all by itself on the left, and I have a less than sign. So that means it's going to be a between. So I'm going to set my equation up as 3x plus 5 lies between negative 10 and positive 10. Solving, I add 5, or subtract 5 from both sides. I have minus 15x is less than or equal to 3x is less than or equal to 5. And if I divide everything by 3, I have negative 5 is less than or equal to x is less than or equal to 5 over 3. If I want to write that in interval notation, it would be closed on both sides because we have less than or equal to for both. It would be negative 5, comma, 5 over 3. Let's try another one. Let's try 7 is less than the absolute value of 5 minus 2x. I need to switch these around because I need my x to be on the left-hand side in order to be able to solve and graph. So I'm going to flip it around, and remember when I flip it around, I also flip my inequality sign around. So I'm now going to have the absolute value of 5 minus 2x is greater than 7. And this is going to follow the absolute value of x is greater than c, which means it's going to be outside instead of inside. So my answer is going to be x is greater than c, or x is less than or equal to negative c. So I'm going to work on this, or 5 minus 2x is greater than 7, or 5 minus 2x is less than negative 7. So this means on the first one it's going to be negative 2x is greater than 2, which means x is less than negative 1 because I'm dividing both sides by negative 2, so I flip my sign around. Over here I have, if I subtract 5 from both sides, I have negative 2x is less than negative 12, which means x is greater than 6 because once again I am dividing by a negative number, which flips my sign around. So if I graph this, I'm going to have a parenthesis at negative 1, and my graph will go to the left because that's x is less than negative 1. I have a parenthesis at 6, and it will go to the right because x is greater than 6. Big caution here. This is a trick question, and you know I'm going to throw this at you. The absolute value of x equals negative 2 has no solution because the absolute value, distance, can never be negative. So if you have a less than sign and you work your problem down to where it's less than negative 2, it has no solution. For instance, if I have negative 2 times the absolute value of x minus 3 is greater than 4, you're going to be really tempted to look at that greater than 4 and think that you know what the solution is, that it's going to be outside instead of inside. But what you have to do, once again, the most important part is get your absolute value by itself. If we divide both sides by -2, we have the absolute value of x minus 3 is less than -2, which we can work with. Or which we can't work with because you cannot have an absolute value that is less than -2 because distance can never be negative. So be careful. You know I'm going to throw one of those at you on a quiz or on a test. Okay, go do your checkpoints and we'll work on the homework in class. See you around. Bye.